Okay, everybody, today we're going to have a little bit of a lesson review on how to draw dot structures. So if you missed our lesson in class about how to draw dot structures, the first thing you need to do is make sure you go over a couple handouts which I'll show to you, which you can find in Schoology. A couple of handouts and and a PowerPoint with the guided notes, okay? But I just want to do a quick overview how to draw dot structures. I'm also going to show you how to determine the shape of a molecule, but I'm not going to go into a full lesson on determining the shape. I'm just going to show you how to use the chart that's on one of your handouts, okay? Once you draw a dot structure and you have the dot structure of a compound or molecule, how do you determine the shape of that molecule? And right now, I'm just going to show you how to reference a chart, okay? We'll do another lesson later where I'm going over the shapes of the molecules a little bit more in detail, all right? But again, if you missed this in class, if you weren't here for some reason, you really should look at these handouts. So the first handout is the Drawing the Dot Structures handout. You should really read through these notes here. And then this is the chart right here that I'm going to show you how to reference to determine the shape of a molecule, okay? And then also on the back here, we're going to be going through these steps on how to draw a dot structure. But make sure you read through them. And again, in today's lesson, we're going to be following these steps. So you want to kind of read over them beforehand to understand what we're doing. The other thing you're probably going to want to do is, look at the guided notes that are posted in Schoology and the PowerPoint that goes along with the guided notes, so you can check that out before watching the rest of this video, okay? Okay, so let's get into how to draw dot structures. Now, there's a couple different methods on how to do it. The steps that are listed here on this handout are good for pretty much any dot structure where you have one central atom. But the first one I'm going to do is talk about a simple procedure for pretty simple molecules, and it's called the puzzle method. And so if I wanted to draw the dot structure of H2O, a molecule of H2O, the first thing is kind of identifying the numbers and types of atoms in one molecule. So that's what the formula tells us. So in one molecule of H2O, I got 2 hydrogens and 1 oxygen, okay? And so if you're thinking about drawing a dot structure of this molecule using the puzzle piece method, what you want to do is draw the individual dot structures of each of these atoms. So we got 2 H's and we got 1 oxygen. So oxygen has 6 valence electrons, so 6 dots in its dot structure. And hydrogen has 1 valence electron, so 1 dot. All right, so here's one of my puzzle pieces. Here are my other 2 puzzle pieces. And what you want to do is highlight the electrons that are unshared, not unshared, unpaired. Okay, so these 2 electrons on the same side and these 2 electrons, they're paired. Okay, that's called a lone pair or sometimes called an unshared pair, but that's a pair of electrons. But these 2 electrons right here, those are unpaired electrons. And this electron here is unpaired, and that electron right here is unpaired. So you want to look for those electrons, and you're not going to focus on the ones that are already paired up, okay? And so if we highlight the unpaired electrons, those are the ones that are going to bond first, okay? So you need 2 electrons to make 1 bond, okay? Well, here's 1 electron, and here's 1 electron, so they can make a bond. Here's 1 electron and here's another electron, they can make a bond, okay? So you can connect what you think might be the bonds. So here's 1 bond, here's another bond, okay? And after you do that, you wanna see if you are satisfying the octet rule for everything. But one thing you wanna look into, again, is this set of notes up here, and this tells you the octet rule for different types of atoms. So oxygen is a must-have 8. So in its final dot structure, oxygen has to have 8. But hydrogen doesn't want 8, it only wants 2. So it's really the octet rule for pretty much everything except for hydrogen, which is, you can think of it as the duet rule, okay? So if we go back to the lesson here. So I got 2 electrons there being shared between the 2 atoms and 2 electrons there, so we can write it like that. So when they're being shared between the 2 atoms, they count both ways. Okay, but another way to show electrons being shared, instead of drawing 2 dots between the 2 elements, is to draw a single line. So that line there, that dash, is equal to 2 dots being shared. So this right here is the same thing as these electrons being shared by both. Okay, and now here's the deal. When you have shared electrons, a covalent bond, they are shared both ways, meaning they count for both atoms that are sharing it. So right now there's 2 electrons represented by that line, and that's 2 electrons for that hydrogen, okay, and 2 electrons for that hydrogen. But then if you look at the oxygen, we got 2, 4, 6, 8. So oxygen satisfying the octet rule, hydrogen satisfying the duet rule, and that's your dot structure. There you go. We just drew the dot structure for water, okay? So if I asked you to draw a molecule of water, it looks like this, okay? Now, real quickly, I'm not going to go into this too much in detail because today I just want to focus on how we get the final dot structure. But let's talk about shape. A lot of times you draw the dot structure so you can figure out the shape of a molecule. So let's figure out how we got this shape. So the shape of a water molecule is called bent, but how do we get there? Okay. So when you're talking about the shape of a molecule, what you're going to do is you're going to count how many different pairs of electrons you have, how many types of electrons you have, how many domains of electrons you have around the central atom of your molecule. So the oxygen is the central atom, and you have 2 lone pairs, and you have 2 bonding pairs. So let's go to that chart that I referenced beginning. So we have bonding domains, we have 2. In lone pairs, we have 2. So whenever you have 2 bonding pairs, 2 lone pairs around your central atom, the shape of that's going to be bent. Okay, so how do you figure out the shape? Well, you're going to get familiar with this chart, but until you get familiar with the chart, you're going to want to have it out to reference. And so again, if I say, hey, what's the shape of this molecule? You'll say 2 bonding domains, 2 lone pairs. I'll go to that chart and see what shape it corresponds to. Okay? All right, but let's get back to dot structures. All right, so let's try the same thing for CO2. So if I asked you to draw a molecule of CO2, again, figure out what the puzzle pieces are. We got 1 carbon, we got 2 oxygens. So I got an oxygen, and I got a carbon. Carbon has 4 valence electrons, so 4 dots, all unpaired. Okay, oxygen has 6 valence electrons, so 6 dots. 2 of the dots are unpaired, and 4 of the dots are paired. Okay. So again, what we want to do is focus on the unpaired ones. So we don't care about these and these, but we do care about this one, and then all 4 of these, unpaired, 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 unpaired. Same thing here, okay? And we want to figure out how we can connect the dots. So connect an unpaired electron to another unpaired electron over here. Same thing over here. Boom, we can do the same thing over here. So now all of our unpaired electrons are paired. And we would have an oxygen with 4 electrons between the carbon, and then over here we'd have oxygen with 4 electrons between the carbon. So remember, a single dash counts as 2 dots. So if we have 4 dots being shared, that's going to be 2 dashes. That's a double bond. Okay, so that's 4 electrons being shared, 4 electrons being shared. You can draw it this way, that's fine, and sometimes you might actually see it drawn this way. Just remember, if they're in between 2 of the atoms, they are being shared. Okay, so we could draw it this way, or we could draw it that way. Okay, and now let's check the octet rule. Remember, if they're being shared, they count both ways. So I got 2, 4, 6, 8 electrons for the carbon, and carbon's a must-have 8, and each oxygen has 2, 4, 6, 8. So 8 electrons for the carbon, satisfying the octet rule for carbon, 8 electrons for the oxygen, satisfying the octet rule for each of the oxygens. So there we go. That's my molecule. Okay, that's my dot structure. Okay, so now let's go to the shape. All right, so what we're going to do is look at the central atom, just the central atom, when we're trying to figure out shape. We're not going to look at the atoms coming off of it, and we're going to count how many bonding domains we have and how many lone pair domains, and we're going to go to that chart and see what the shape is, okay? So what we want to understand is a bonding domain could be a single bond, could be a double bond, could be a triple bond. So a double bond doesn't count as two electron domains. It counts as one domain. So this is one bonding domain. This is one bonding domain. It doesn't matter that it's a double bond. So yes, it's 4 electrons being shared, but we call it one domain, okay? So we have 2 bonding domains around this carbon, but 0 lone pairs around this carbon. So we go to our chart and we're looking for 2 bonds, 0 lone pairs, linear. Okay, so another example of a linear molecule is HCN, but we're not looking at that. Any molecule that has 2 bonding domains around the central atom and 0 lone pairs around the central atom is going to be considered linear. So if I asked you the shape of CO2 and you drew its dot structure, now we know the shape of that molecule is linear. Okay, all right. So that's how to do it. Like, you can try the puzzle piece method if you're asked to draw dot structures, but if it starts to get confusing and you're not sure how it's going to connect, then follow these steps. Okay, so again, the steps are listed here, and I'm going to go through a couple of examples. All right, so we're going to follow these steps. So let's look at the carbonate ion. So what if you were asked to draw the dot structure of a carbonate ion? Okay. So we got 1 carbon, we got 3 oxygens, but we also have to understand what the -2 is. -2 means 2 more electrons. So there's going to be 2 extra dots in this structure. All right, that's what -2 means. You've gained 2 electrons, right? Okay, so if we were trying the puzzle method, we got that puzzle piece, we got that puzzle piece, we got that puzzle piece, but then that 2 minus is 2 more dots. So I'm gonna have to throw 2 more dots in there somewhere. Where do they go? What's happening? I'm not sure. So the puzzle method, it's not really gonna work for me here, okay? So I'm just gonna follow the steps listed on that sheet of paper. So the first thing is count how many dots your structure should have. So let's think about it. Carbon's coming in with 4 valence electrons. Each oxygen's coming in with 6 each. And then you got 2 more electrons for the -2 charge. Okay, so we got 4 for the 1 carbon. We got 6 valence electrons for each oxygen, and we got 3 of them. And then +2, and again, that +2 comes from that -2 charge. Okay, so if we add them all up, we got 24 dots. So what does that mean? It means when it's all said and done, our dot structure has to have 24 dots. It can't have any more than that. It can't have any less than that. And let's remember, a dash counts as 2 dots. So we need 24 total dots, 24 total valence electrons. All right. So once we count the dots, we got to figure out what's our central atom going to be. So some rules to remember: it can't be hydrogen. Okay. And usually the rule is it's the least electronegative atom in the molecule. So if we go back and remember our electronegativity trend, oxygen is the second most electronegative element, only second to fluorine. So that means carbon, of these 3 puzzle pieces, carbon is the least electronegative. So that's going to be our central atom. Okay. So in this case, carbon is central. Okay. So the next step is, once we figure out what's going to be central, we're going to draw our central atom in the middle, and then we're going to draw single bonds to the other atoms. I refer to them as ligands. Okay, but you've identified your 1 central puzzle piece, okay? So you're gonna put that in the middle, and then you're gonna draw single bonds, so that's just single dashes, to the other atoms. In this case, the other atoms are oxygen, okay? So we have 3 different oxygen atoms, so we're gonna draw 3 single bonds coming off of our central atom, okay? So we got that. Next is satisfy the octet rule for each of the ligands. So the ligands, again, are the oxygens coming off of the central atom. So we got to satisfy their octet rule. So remember, every atom kind of has its own unique octet rule. And oxygen, if we go back to our chart, or we go back to our notes, oxygen is one of the must-have 8s. So oxygen needs 8. And right now in our dot structure, this oxygen has 2, right? The dash counts as 2 electrons counted both ways. So right now the carbon has 6, 2, 4, 6, but this oxygen only has 2. This oxygen only has 2. This oxygen only has 2. So now we have to add electrons to the oxygen to satisfy its octet rule, and oxygen needs 8. So the way we do that is we add lone pairs or unshared pairs around each of the oxygens. So to get to 8, we're going to have to add 3 lone pairs to each oxygen. So we add 3 lone pairs, 3 lone pairs, 3 lone pairs or unshared pairs to each oxygen. And now this oxygen has 8, 2, 4, 6, 8. This oxygen has 8, this oxygen has 8. So we're satisfied the ligands, not necessarily the central atom, but the ligands are satisfied in terms of the octet rule, all right? At this point, we're gonna double check, okay? We're gonna double check the number of dots we have in our structure and see if it's how much we need. In this case, it is. If we count all these, right, I got 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. I got 8 times 3, so I got 24 dots in the structure. That's how much we needed, 24 dots, and that's how much we have. So what does that mean? It means I cannot draw any more dots into the structure. I have 24, and that's the max I'm allowed, right? 24. Okay. So I'm gonna show you another example what happens when you get to this point and you need to add more dots. But in this case, we can't add any more dots, all right? But we're still not done yet because we have to satisfy the octet rule for the central atom. And if we remember, carbon is a must-have 8. And if we leave, if we leave this dot structure as written like this, carbon's not satisfying its octet rule. 2, 4, 6. It only has 6. It needs 8. Okay? So how do we do it? All right? So carbon has 6 right now. How do we do it? A lot of people make this mistake and they just say, oh, okay, I'll just add 2 more dots to the carbon. And that would give carbon 8, but that's going to violate the rule. We can only have 24 dots. And if we just add 2 more dots to satisfy carbon's octet rule, now I have 26 dots, but my structure can only have 24. So we can't do that. So don't just willy-nilly add dots, okay? You have the maximum number of electrons in your structure as is shown here. So we got to get creative. We got to figure out a way to satisfy carbon's octet rule. And remember, we have double bonds, we have triple bonds. And all you need to do to make a bond is you need 2 electrons. Well, here are 2 electrons. How about we take those 2 electrons and make it a double bond instead? All right, and that's what we're going to do. We call that a coordinate covalent bond, where the electrons from the bond come from one atom. So these 2 electrons come down and we form a single bond. So now this oxygen on top only has 2 unshared pairs. One of its unshared pairs goes in and gets shared. So now if we look at this structure, this oxygen has 2, 4, 6, 8. These oxygens have 8. And now the carbon, because we added that double bond, 2, 4, 6, 8. Okay? So that's our dot structure for the carbonate ion. But whenever you have an ion, whenever you draw a dot structure, the first thing you need to do is make sure you include the charge. So we put it in parentheses and we say 2 minus outside to let us know we have 2 extra electrons in there. Okay? But that's not the only thing. So this is not, this is more of the next level thing, but it is in your notes. And it says the very last step is draw possible resonance structures. So let's understand what that means in this case. So we took those 2 electrons and made the double bond there. But couldn't we have done it here? Those 2 electrons and made the double bond here, or maybe take those 2 electrons and make the double bond here, right? We could have made the double bond anywhere. So that's what you have to show. So the resonance structures of carbonate are really, you have the double bond here, or you draw the structure with the double bond there, or you draw the structure with the double bond there. And so carbonate technically has 3 resonance structures, And so the way we draw that is we draw double arrows connecting the different possible structures, and then we still have to include the charge in this case because it is a charged ion. So these are the resonance structures of carbonate. Now, not everything has resonance, and you're really not going to be totally responsible for resonance structures, but it's just something to kind of put in the back of your mind, just in case for some reason you decide to take AP chemistry. Resonance will be something that's important to know, okay? So, you know, if you could get, if I say, hey, draw the dot structure for carbonate, and you can get to here, and you don't include the resonance structures, that's perfectly fine, okay? But anytime you get to this point where, wait a minute, well, I just drew the double bond on top just because, I don't know, I started at the top. But anytime you get to a point where the double bond that you're making, or maybe even a triple bond you're making, could be added at different positions, then technically you have to show each possible structure, okay? Now, when you're in class, we'll talk about the ramifications of resonance, what it really means, okay? But let's get to shape. All right, so it doesn't matter if you draw resonance or not. Let's talk about the shape, okay? So again, now if I want the shape of the molecule, I'm going to look at the central atom, and I'm going to count how many bonding domains I have and how many unshared pairs I have around just the central atom, okay? So here's my central atom. I got 1, 2, 3 bonding domains, 0 lone pairs. So I'm going to go to my chart, and I'm looking for 3 bonds, 0 lone pairs, and the shape is called trigonal planar. Trigonal planar, it means it's a triangle, and planar means all the atoms are in the same plane, all right? But whenever you have any molecule, so here's another example of a molecule that ends up with 3 bonding domains and 0 lone pairs. Anytime you have that combination around your middle atom, the shape of the molecule is called trigonal planar, okay? So there we go, there's the shape. All right, so hopefully you're starting to get a feel for this. Let's do one more example. So let's say I wanted to draw the dot structure for PCl3, okay? So the first thing is, count how many dots you need. Phosphorus comes in with 5 valence electrons, and each of the chlorine come in with 7 valence electrons. So we got 3 chlorines, so 7 plus 7 plus 7, and then we got 5 from the phosphorus. So we have a total of 26 dots. So when all is said and done, we need 26 dots in our final structure, all right? Then what do? We decide on the central atom. Phosphorus is less electronegative than chlorine, so phosphorus is going to be the middle. So we put phosphorus in the middle, and we draw single bonds to our ligands. So we have 3 of them, 3 chlorines, so 1, 2, 3, okay? We satisfy the octet rule for chlorine. Chlorine must have at least 8, so we need to add the 1, 2, 3, we need to add the 3 lone pairs for each chlorine to satisfy the octet rule for the ligands, okay? So the chlorine has 8, that chlorine has 8, that chlorine has 8. And now we double check. Okay? So this structure, the way I have it drawn now, we have 8 electrons here, 8 electrons here, 8 electrons here. We have 24 dots, but remember, we needed 26 dots. So this is the time where, hey, when you double check and you don't have the correct number of dots and you need to add more, we add any remaining dots to the central atom. So how many more do we need? We need 2 dots, and so we add lone pairs to the central atom until we get to the correct number. So we need to add 1 lone pair, because 1 lone pair or 1 unshared pair has 2 dots, right? So we add it to the central atom. So there we go. We have our dot structure. It has 26 dots now. We have 8, 8, 8, and then plus 2. So we have 26 dots. Okay, now let's check on the octet rule. The octet rule is being satisfied for everything. 8 for each chlorine. And now with that lone pair, 2, 4, 6, 8 for the phosphorus. So octet rule being satisfied, check. Number of correct dots, check. So that's going to be our dot structure. And you can leave it there. But another thing you want to start getting used to is trying to represent the shape of the molecule a little bit better in your final structure. And so let's understand, like, these electron domains that are around the central atom, they want to spread out as far away from each other as can, because what do electrons do to each other? They repel. So these electrons want to be away from the other electrons. And so they're going to spread out. So you don't have to do this, but it kind of helps you understand the shape a little bit more, is you want to reference this document. It's called Polishing Up Your Dot Structures. And so let's find our combination. So 3 bonding domains, 1 lone pair, right? If we go back to our structure, we have around the central atom, we have 3 bonding domains and 1 lone pair. So the polishing document tells us this is how we are supposed to represent it. So instead of drawing it this way, we're going to polish it up and draw it this way with the lone pair on top and the 3 bonds like this. Okay. Now, again, you don't have to do that. You could leave it like this, but this is the polished up structure. And then let's find the shape. Let's figure out what the shape is. Okay, so it doesn't matter which dot structure you're looking at. If you look at this one around the central atom, 1, 2, 3 bonds, 3 bonding domains, 1 lone pair. Same thing around this one. 1, 2, 3, 3 bonds, 1 lone pair. We go to our chart. We're looking at 3 bonds, 1 lone pair, trigonal pyramidal. Okay, so when you had 3 bonds and 0 lone pairs around the central atom, we would call that trigonal planar. But now, when we have 3 bonds and 1 lone pair around the central atom, that's called trigonal pyramidal. And when we bust out the model kits and we see what these actual molecules look like in 3 dimensions, not the 2 dimensions on the piece of paper, that's when we'll kind of understand why do we call it a triangle pyramid? And it'll make more sense when you see a 3D model of the molecule. All right. So that's just kind of a quick, a brief lesson on how to draw dot structures. And just like with a lot of things, it takes practice, and you'll start to notice patterns. And a lot of times, when it's early on, if you're asked for the shape of a molecule, it's good to draw its dot structure. But eventually you'll start to see patterns where it's like when you have carbon with 4 things or silicon with 4 things, it's always tetrahedral. So you're going to start noticing patterns where you'll be able to know the shape just by looking at the formula and the types of atoms that are in the formula. Okay. But, it's good to be able to draw dot structures and kind of understand when you're given a dot structure, what everything represents. And the other thing I'll stress as we move forward is you always have to think about 3 dimensions, not 2 dimensions. So we're drawing these structures on the whiteboard, we're drawing these structures on a piece of paper. They're represented to us on a piece of paper, which only has 2 dimensions, but we have to remember that these molecules can spread out into the 3 spatial dimensions. They're 3-dimensional objects just like we are, so you have to always think about that in the back of your mind. The dot structure written on a piece of paper is not always a good representation of the actual shape of the molecule. All right. Okay, so that's it. Have a good one.